So section 7.3 is on anti-differentiation by parts. Shh, guys. They say this is not on the AB exam, but it could be really useful if you get something that you do not know how to integrate. You could use integration by parts. All right, it's very easy. All right, so if you remember the product rule for derivatives, said that if you had f of x times g of x and you took the derivative, you'd get f of x times g prime of x plus f prime of x times g prime, or g of x. I don't remember where I was going with this. So if we integrate the right side, f of x, g prime of x, dx. Okay, so if you integrate the right side, you would have the integral of f of x, g prime of x, plus, or dx, plus the integral of f prime of x, g of x, dx. So rearranging, this would all equal f of x gx, right? If you integrate both sides, I guess. So rearranging, if you have this one and you subtract this one over, you would get f of x times g of x minus the integral of f prime of x, g of x, dx. Okay, this is called the formula for integration for parts. But it's much easier if you replace all those of x's with things that are easier. So we use it with u and dv. So it's u is your f of x, dv is the derivative of g, so g prime dx. So you have u, v is fg, minus v is g of x, right? dv was g prime of x dx. So that means v is just g of x, and then du is the f prime dx. Okay, so we remember this formula. So the integral of u dv equals uv minus the integral of v du. All right, I make it even easier than that, and I just remember a little pattern based on how I write it. So you always are going to have a u and a dv. And you always try to get it to be something that vanishes. So when I say vanishes, I mean that when you take the derivative of it, it's slowly going to go away, right? So eventually you'd get, when you take the derivative, you get 0, right? So am I going to let it be x or cosine of x? X. All right, so that means dv is going to be the rest of it, cosine of x dx. We always put the d part with the dv. All right, so now what we're going to do, so once we write those two different things, I'm going to take the derivative of u and I'm going to integrate the dv. Integrate, deriv. So the derivative of u would be what? 1 dx. And if I integrate cosine of x dx, what is that? Sine of x. Okay. This, I always have this little like square of 4 different things when I do this problem. Okay, here's the pattern. So you're going to do uv, so u times v, and then you're going to do the bottom row, v du. Okay, you never use that dv. So you're going to do uv, so it's going to equal uv, so x sine of x, minus bottom row, so sine of x dx. And this is something you know how to integrate. So we didn't know how to integrate x cosine of x, so we use integration by parts. But now we know how to integrate sine of x, right? So I get x sine of x minus negative cosine, so plus cosine of x, plus c. And that's your answer. Okay, so that takes us to one like this. So this one, it's kind of hard to see. It's like, does this vanish? What's going on? So we have our u and we have our dv. Do you know how to integrate natural log of x? No, right? We don't know how to integrate natural log of x. So that's probably not going to be your dv. So we're going to put natural log of x as our u. Dx is the dv. Let's see what happens. When I take the derivative of u, du is 1 over x dx. When I integrate dv, what do you get? X. So you should be like, oh no, it's not going to go away. I'm going to get even more and more. All right, but this one actually works out nicely because when you do your parts, you have uv. So uv is x natural log of x minus the bottom row, v du. So what happens? Yeah, you get 1 over x times x dx. So you get x natural log of x minus the integral of 1 dx. So x natural log of x minus x. And that's your answer. Oh, plus c. Can't forget that. Okay. So most of them are pretty easy. It's pretty easy to tell what your u is and what your dv is. Some of them do get kind of hard, though. So number 3 is one that gets kind of hard because it says use integration by parts twice. So we're going to use it twice to find x squared sine of x dx. Okay, so we're going to let u be x squared. dv is going to be sine of x dx. du is going to be 2x dx. v is going to be cosine, negative cosine, right? Okay, so I get uv, so negative x squared cosine of x. So I'm always doing the downwards diagonal, then the bottom row. All right, minus. I have 2x times a negative, so plus the integral of 2x cosine of x dx. Did you see why we have to do it twice? Now you can pull out that 2. That's no big deal. You don't have to, but I think that way we just don't have a 2 altogether. Okay, now we do it again. So whenever I do it again, I usually put little subscripts, 1, 1, 1, 1 on those ones. And then I say u2 dv2. So u2 is going to be x, du2 is dx.
So we're just doing this on the latter half of the
Yep,
problem?
we're just figuring out this. Yep. All right, dv2 is cosine of x dx. So you need sine of x.
Negative sign?
Nope, because when you take the derivative of sine, you get cosine, right? Going backwards. All right, and it doesn't matter how you do this. I mean, like Rachel's saying, like you could just write up that second half right there and just find that first and then plug it into the last one. You could do that. Or you could write it all out together. It doesn't matter. So let's say we just do this part. So if I do this part, uv is x sine of x minus the integral of sine of x dx. So it's x sine of x minus, well, plus cosine of x plus a c at the end. So that means this final answer is negative x squared cosine of x plus, you have a 2 on the outside, so you're going to multiply it, so 2x sine of x plus 2 cosine of x. You can say plus 2c, but we usually just say plus c. It's still just a constant, right? That's your answer.
Did you add the 2 together?
I had this 2 here, so I multiplied it in to all of that. that what you're asking?
Wait, so you took the answer that you got from the first part?
I was doing this part off to the side. So I put it up there.
Oh, yeah.
All right. Making sense? Pretty easy. I mean, it's not really a hard formula to remember. Okay, so the next one. These ones are the hard ones. So when they have e to the x or e to the 2x or something like that, and they have sign, because nothing vanishes. Does that make sense? How nothing would go away as you're taking the derivative. But these will actually work out. You can let it be either thing. It doesn't matter. I'm going to let it be e to the 2x and sine of x dx. And you'll see the trick on these ones. So du is e to the 2x times 2, so 2 e to the 2x dx. V, so what do you take the derivative of to get sine out? Negative cosine, yeah. Okay, so you have e to the 2x times negative cosine of x minus 2 e to the 2x times negative cosine of x, so we change it to a plus, dx. Okay, so hopefully you see you have to do it again. So make those subscripts 1. I'll do it again over here. So I'm going to do e to the 2x again. Okay, so that means I'm replacing this integral. So it's now negative e to the 2x cosine of x plus 2 times e to the 2x sine of x minus the integral of 2 e to the 2x sine of x dx. So what's happening? Yeah, we call this recursive because it keeps continuing. You keep getting that same thing. So here's what I always did when I was in school. I called this original w. So I'd say let w equal. Do you guys see that this is also w? W. So all of that is equal to e to the 2x sine of 2x, or sine of x dx. All of it's equal to w. So we now have an equation set up that's going to allow us to solve for w. Okay, so I'm going to rewrite. So I'm going to say we have e to the 2x cosine of x, negative out front, plus 2e to the 2x sine of x, minus, that would be 4w because you had a 2 out front, this 2 right here, times a negative 2. So minus 4w equals w. Did you guys see how we solve for w? Yes? Did you guys see it?
Oh.
Yeah, put w's on both sides. 5w. And then divide by 5. So you get negative 1/5 e to the 2x cosine of x plus 2/5 e to the 2x sine of x equals w, which was that original integral, e to the 2x sine x dx. But be really careful because what did I really leave out? I left out one little thing that I need to add in.
C.
C. So you should really say plus c because you could have any constant.
What happens in our final, or like on our AP exam, I guess? Would you write W equals, or?
You would need to define what w is. You would need to say let w equal the original.
Okay,
Yeah.
that's okay.
Mm-hmm. Yeah, it kind of saved you some writing. I mean, you could write it with all the integral, but it gets kind of annoying. So, all right. All right, so calculate x cubed natural log of x dx. This one won't be one of those ones where we have a w. It won't be bad. So what should we let our u be? X cubed, natural log of x. Natural log of x. Why, Catherine? I can't hear you, but I'm going to guess that you're saying something about how natural log of x, I don't know how to integrate that. I mean, we did in this example back here, but I really don't expect you to memorize that. It's not too bad. Okay, so du is going to be 1 over x dx. dv was x cubed, so when you integrate it, you get x to the fourth with a 1/4 out front. Okay, so you get uv, and this is one where it's nice to just leave off the numbers. See how you have 1 to 2? Just leave them off for now. And I would just write x cubed natural log of x. So find what this is first, and then use the numbers. Okay, so x cubed natural log of x is going to be, when you integrate, you get uv, so 1/4 x to the fourth natural log of x, minus, you have 1 over x times 1/4 x to the fourth. So you have a 1/4 out front. 1 over x times x to the fourth is x to the third dx. So you get 1/4 x to the fourth natural log of x minus 1/4 times 1/4 x to the fourth plus, you would normally have a plus c, right? Now, if you did put numbers in, your numbers would go like this. You don't have to do this, but you would need to do a 1 to 2 there, a 1 to 2 here. I mean, you need to keep track of all those 1 to 2s. So you know when it's outside of the integral sign, you need a line 1 to 2. That's why I was saying it's sometimes easier just to leave them off and then do it at the end. So you have 1 to 2, x cubed natural log of x would be 1/4 x to the fourth natural log of x minus 1 over 16 x to the fourth, going from 1 to 2. So if you plug in 2, you get 16 times 1/4, so 4 natural log of 2, minus 1 over 16 times 16, so 1. So that's plugging in 2. When you plug in 1, that's nice. Natural log of 1 is 0, right? So that first part's going to go away. Minus 1 over 16. So you get 4 natural log of 2 minus 1 plus 1 over 16. So think of minus 1 as negative 16 over 16. So you get 4 natural log of 2 minus 15 over 16. Okay. Remember, this could be a multiple choice answer, and it could be on the non-calculator portion. So if you don't have a calculator, I mean, you can't find the decimal approximation to see which answer is correct or use Math 9 or anything. So what if they had this? That's correct. What did I do to get that answer? Yep, you took the 4 and you raised it as a power on the 2, right? And remember your rules of logarithms, because that's going to happen a lot on your multiple choice. We're going to have different forms, and you have to remember what your answers are, how they're right. Okay, last one. So find a formula for x to the n natural log of x dx, where n is a number not equal to -1. Okay, so we're going to figure out a formula. So let's let our u be natural log of x, just like we did in the last example. dv is going to be x to the n. The d's always have the dx's, right? du is 1 over x dx. How do I integrate x to the n? 1 over n plus 1 x to the n plus 1, right? You add 1 to the power and then do 1 over that new power. So you'd have 1 over n plus 1 x to the n plus 1 times natural log of x minus the 1 over n plus 1 is just a number, so pull it on the outside of your integral or your integration sign. So you have 1 over x times x to the n plus 1 dx. So what does that become?
X to the n.
This is all x to the n. So when you integrate, you have 1 over n plus 1 x to the n plus 1 times natural log of x minus 1 over n plus 1 times, if I'm integrating x to the n, it's 1 over n plus 1 x to the n plus 1 plus c. So you get 1 over n plus 1 x to the n plus 1 times natural log of x minus, we would really combine these. So I'd say 1 over n plus 1 squared x to the n plus 1 plus c. So that would be the type of formula that would be like in the back of your book. Okay. So it would be very generic for any n value. Yes?
So on the other side, the equal sign, would it be equal to the original problems, like the integral of x to the n natural log of x?
Like on the other side of the equal sign?
Yeah.
Yeah, like you could put that there.
Okay.
Yeah.
Where you have it circled in red.
Uh-huh.
How does that equal x to the n?
Because 1 over x is x to the negative 1. So when you multiply by x to the n plus 1, you add their powers. So it'd be x to the n then. Oopsie.
So would that be your final formula?
That's it. Yep.